So welcome to the channel guys. I hope you all are fine and doing great. Today we are going to discuss this GFG problem of the day, cousins of a given node. Okay. So let's move on to the problem. So what we are given? We are given a binary tree and a node. And what we have to do? We have to print all cousins of node. Like here node is equal to 5. So we have to print all cousins. So 6 and 7 its cousin, so we just print 6 and 7. Here we do not print 4. Why? Because 4 and 5 are siblings and we don't have to print siblings. Okay, here you can see siblings should not be printed. Why they are sibling? Because the parents of both 5 and 4 is 2. That's why we do not print 4. Like in this case, here given node is equal to 5, here 5, but as you can see here there is 0 node who are cousins of 5. That's why we just print -1. Okay, so guys, let's move on to the solution. So this is the basic idea. Now what we are doing, i am I am telling you. First of all, we take a variable found and a variable n, and n store the value of my node that I need to find. Here as you can see, our function is given, our root node it is, and this is our node to find, the node that we have to find. Okay, so n will uh, represent the data of the node I have to find, and I just take a queue, I push my r in my queue, and I take a vector int. That will be my answer. Okay, so guys, what I am doing, I am initially taken the size of my queue. I am just doing travel order traversal here. Okay, so as you can see, I take a queue. uh, Wait a minute, I take a thing. Okay, so I take a queue initially contain 1. Okay, queue initially contain this. Now after this one, we will take the size in s, and our check is equal to found. What is our check? Our check means whether the current level is the level where our node to find is present. Now we will update my found in each round. How I will update my found? Just look at this function. I will explain you. I am explaining you. Okay, so I am running a for loop for the size of the queue, so that each node of that particular level is completely pop out. Okay, like if my queue is at this level, then it has 3 and it has 2. Okay, so size is equal to 2, and what we do, we will pop out 2 and we will pop out 3 and we will push back 4 5 6 7. Now we will see whether we need to pop back and push back. Okay, so here you can see I will take a node x and I take the front of my queue in it and I just pop out it. Okay, if my check means if this is the level where my node is present, so I just push back my the data of that node in my vector v, and I just do continue. Okay, else if this is not the level, then what I do, I will check whether the children of my x node, the whether the left or the right children of my x node have data is equal to n, Okay, then what we do, we will do found is equal to 1. Found is equal to 1 means in a particular level, like here when we are at 2, uh, our found will be is equal to 1. Okay, so else and what we do, if and I do continue. Why I do continue? Because when I found a like here when I am at 2, I will found a node whose data is equal to node to find, and I don't need to push back 4 and 5 because I don't need these two particular number. I don't need 5 because 5 is the number, and I don't need 4 because 4 is the sibling. Okay, that's why I just do continue. Else while what I do, if my x dot left is not is equal to null, means if it has some address, then I just push back the address, and if my right had some value, then I just push back my right. And if my check is equal to 1, now here you can see when I found a level, I just make it 1, and in next iteration my check is equal to found. So if my found is equal to 1, then my check is also is equal to 1. Like for this round my check is equal to 1 when my k contain 6 and 7. So here I take node, pop out this. What I do, if my check, yes, my check is equal to 1, I just push back and I just continue. So my this loop will not work. Okay, so similarly, my 6 will push back in my vector, my 7 will push back in my vector. Okay, so, and if my check is equal to 1 means I had found the number, then I just return v because I had my complete vector now. Okay, else while what we return, we just return -1. Okay, now what we are doing, suppose if we have to given the node 3. Okay, here 1, so x is equal, so in first iteration, what will happen, in first iteration, x is equal to 1 means x is point to this, x is point to this. Okay, now as you can see, uh, my x x right data. Okay, this d means data is equal to n, so here my found is equal to 1, here my found is equal to 1, so now my found is equal to 1 and I will not push back 3. I will not push back 3 and 2 as well. Okay, I will not, I because as you can see, I just continue it. If I found, I just continue it. Okay, so my queue is equal to empty. So my queue is equal to empty now because I don't push back anything and I pop out this one as well. Okay, so I just return -1. So okay, so I can show you answer. If my 3, it should return -1 because we don't have any cousin, we have just 2, as you can see also. But okay, but if we have 5, we need to 5. Just a minute, just a minute. Okay, okay, our x is equal to 1, our q is equal to, now we have to found this 5. Okay, now our queue will contain, this is our queue, our queue will contain 2 and 3 because either left or right child of my node 1 will not contain 5. Okay, so now when my queue is equal to this. Okay, so in second iteration, now in second iteration, now what happens in second iteration, my x is equal to 2, my x is equal to 2 and my q will be like 3 because I just pop out my 2. Okay, you can see I do q dot pop. Okay, now my x is equal to 2. We will check whether our x left or x right is equal to 5. Yes, x right is equal to 5. So what we do, we will do our found is equal to 1. Here found is equal to 0, so this condition will not work here. Okay, found is equal to 1, yes. Okay, so and I what I do, I just continue, so my q will not update in second iteration. Now my q is equal to 3, my q is equal to 3. As you can see, my size of q is 2, so I run a for loop for size is equal to 2, so my q and 3 will work out. So here and here my okay, okay, yes, my check is equal to, my check is equal to 0 yet. Okay, my check is equal to 0 yet because I update found, but I am updating my check uh, outside my for loop. That's why this check remains 0. Okay, so now what happens, I will I will see if my check, no, this condition will false, this condition also false. I just push back my q dot left and q dot right, so my q will update now like I pop out this 3 and push back both of its left and right children like 6 and 7. So this is my updated queue now. In third iteration, my s will contain, my s is equal to 2 because q is equal to 6 and 7, so size is equal to 2, and my int check is equal to found, my found is equal to 1, my, as you can see, my found is equal to 1, so my check is equal to 1. So my node is equal to front. Now my x is equal to 6. Now I use this 6. Yes, if and as you can see, I have my check. So I just push back my 6 in my vector. Okay, now I push back 7. My x is equal to 7, my check is equal to 1, so it is pushed back. I completed my loop. My q is equal to this now, and as you can see, our check is equal to 1. So if our check is equal to 1 outside my for loop, you can see this is my for loop. Okay, this is my for loop, and we just return v. So our check, we come out of for loop and we just return it to our answer. Okay, and else while if we complete this and we don't found any sibling, or we don't found any cousins, we just return -1. Okay, so guys, I am submitting it. So okay guys, you can see all the 50 test cases pass out, all the 60 cases, sorry, 50 cases are pass out. So I hope you like it, and if you have any doubt, then just comment out. I will try my best to explain you. So guys, you can like the video, subscribe the channel, and check out my channel for more GFG and lead code daily problem solution. So I hope you like it. Thank you for watching this, guys.